everyone and welcome back to Belle Explains. In today's video, we'll be talking about the laws of indices. The first thing you need to know about indices is that there will be a base alphabet or a number, and then there will be a little power at the top. Okay, we're going to talk about power 0 and power 1. So for power 0, we have a base which is x or any number, could be anything, and we have a power which is 0. So any base that has a power 0 will equal to 1. That includes x to the power of 0, which will be 1. And 6 to the power of 0 will also be 1. Anything at all that is to the power of 0 will equal to 1. Second one is power 1. So anything to the power of 1 will be equal to the base itself, because 1 is negligible and you don't have to write it down. For example, 1x, you don't write the 1, right? You only write the x. So similar for the power as well. If there is no power, it means that there is a power 1, which means you don't have to write it there. So for example, 2 to the power of 1 will also be 2. It will be invisible, you don't have to write it there. One number 2, same base multiplication. For same base multiplication, what it means is that the bases are the same. When the bases are the same and you multiply them, the powers can be added. Well, the first one I have here is x to the power of 2 times x to the power of 4. Since the bases are the same, x and x, then the powers can be added. So x to the power of 2 plus 4, and that will give you x to the power of 6. Similarly, if you have x to the power of 0, for example, you can just take 0 plus 2, which will give you 2. The answer will still be x to the power of 2. And lastly, x times x squared. So since there is no power there, it means that there is a power 1. So you take 1 plus 2 for the power, and the base remains as x, so your answer will be x to the power of 3. In contrary, for a multiplication, if we are going to do division for similar bases, we're going to subtract the power. So if we have x to the power of 6 divide by x to the power of 2, what's happening here is that because the bases are the same and you're dividing them, it means that you can subtract the powers. So x to the power of 6 minus 2, and you will get the answer, which is x to the power of 4. If let's say your indices is fraction where there's a numerator and a denominator, what you can do is that you can also subtract them, because fractions are also divisions, it's just written in another form. So if your numerator is x to the power of 6 and your denominator is x to the power of 2, then you can take x to the power of 6 that's from the numerator, can subtract the 2 from the denominator. So your answer will be x to the power of 4. Similarly, if your power is a negative, you can still subtract them, but be aware of the positive and negatives. So in this situation, 6 minus, but since the other power is negative 2, it will be placed in a bracket. Since symbols can't be next to each other, you have to separate them with the bracket. And negative next to each other will give you a positive, so x to the power of 8. Rule number 4, we have power of a power, which means that you have a base number, you have a power, and outside the whole bracket, there is another power. So what happens there is you can multiply the two powers together. So for the first one, we have example x to the power of 2, there's a bracket, and then there's a 6 outside. So remember, when there's a power for a power, you need to multiply the powers. So x to the power of 2 times 6, you will get x to the power of 12. X to the power of 2, y to the power of 3, the whole thing in a bracket, to the power of 6. So when you notice this question, there are two terms that are in the bracket. So the 6 that's outside will multiply them individually inside. Okay, so you can see x to the power of 2 times the 6 and y to the power of 3 times the 6 as well. Remember that it has to go in for all the terms that are in there. If there's a coefficient, then it will also be multiplied for the coefficient. Okay, so your answer will be x to the power of 12 and y to the power of 18. Okay, the same thing as well for division. If let's say it is in a fraction form and there's a term at the numerator and a term for the denominator, you can multiply the power in individually, which will give you x to the power of 12 over x to the power of 18. But this is not the final answer. Remember the third rule, where there's a numerator and a denominator, it is a division function, right? So the powers can be subtracted. You can take x to the power of 12 minus the 18, and that will give you answer x to the power of negative 6. Later on, I will explain why x to the power of negative 6 is still not the final answer. We will get to that later. Inverse functions. So when you have your power which is a negative number, right? For example, x to the power of negative 6, we don't leave our answer in negative form. We always change it to become positive. Since x to the power of negative 6 are numerators, by changing it to become a denominator, it will become a positive function. Okay, so it will become 1 over x to the power of 6. So if it's, for example, 1 over x to the power of negative 6, we don't leave our answer like that because our power is a negative number. We can change it to become positive by making it to become a numerator back again. So that will give your answer x to the power of 6. The last rule is for roots and power fractions. What that means is that whenever you see a root and there's a number outside, we can make that to become a fraction number. So for example, we have a to the power of 4. In a root, we have 5 on the outside. Okay, so a to the power of 4, they are one set, they belong together. However, the root with the 5 outside, that one can be changed to become a fraction. Okay, so that one, it's a 5, right? When you change it over, it can become 1 over 5. So it'll be a to the power of 4. And the 5, we're not going to leave it in the root function anymore. We're going to change it to a fraction. Okay, so it will become 1 over 5. So for example, we have square root. How do I know that this is a square root? Because there's no number outside the root, so it's definitely going to be a square root, which means it's going to be a 2. If I change this square root to become a power fraction, it'll be 1 over 2. Since there's 2 outside and 1 over 2 inside, you can cut out the 2's and it will just leave you with 3 to the power of 1, which will give you your answer, which is 3. Anything to the power of 1 will be the base number. 3 to the power of 6, and outside the root we have a 7. So if we want to change the root, we want to remove the root, it's going to be 1 over 7, right? And then you can multiply the fractions in, because when you have power and a power, you can multiply them together. Another example, if we have x to the power of 7 over 9, in fraction form, it's the numerator multiplied with 1 over 9, right? That's just separating 7 over 9 to become 7 times 1 over 9. So if I have 1 over 9, it means that 9 was the root number. So x to the power of 7 remains in here and the 9 goes out of the root. That's all for today for the rules of indices. Catch us in our next video where I'll be explaining a few more examples on how to apply these laws. See you in our next video. Thank you everyone. Bye bye.